This example gives us a function, and they even give us the graph. And they want us to find the minimum value and the maximum. Now, when they say that, they mean the minimum y value and the maximum y value. In other words, you can see it right here. Here's the max. We can see it on the graph. But the question is, how high up, here's the what is that? This is the y-axis. What is that maximum y value at this point here, which is the local max? So how high up does it go? And then this one down here, here's the min, but where exactly is that on the what is the minimum value at the local min? How are we going to find that? Well, we got to take the function. Let's rewrite the function here. 2x cubed plus 15x squared minus 216x plus 3. And we got to take the derivative. Why? Because that's how you find maxes and mins, is by doing the derivative. Let's do the derivative. So bring that down. That'd be 6x squared, subtract 1. Bring that down. Plus 30 regular x, subtract 1. Minus 216, right? That 1 power comes down, and then subtract 1. That x is gone. And 3 is just gone, 0. Okay, so there's what's out. Then I set that equal to 0. Why? Because that's where maxes and mins are. So imagine if you're on the roller coaster. When you're at the very top of the roller coaster, you're flat for just a second. Your slope is 0. Then you go down, 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 down. And then when you reach the bottom, again, you're flat for just a second. So at the maxes and the mins, the derivative, remember that slope, derivative is slope, is 0. So we're going to know where's the slope, where's the derivative equal to 0. That'll tell us where the max and the mins are. Okay. So I got to solve this equation. What am I going to do? Well, I would factor out a 6 first. Is x squared plus, just use your calculator, you don't divide. You just divide by 6. I just factored out. I think that's a 36, 180, and so yeah, 216 equals 0. I factored out a 6. And then that factor, oh, it does. Now if you can't tell, you can do the quadratic formula. I'm going to factor it. I can tell. This is f OIL, front times front to make front, last times last. What makes 36? Well, a lot of things. 4 and 9 is what I want. Sign in the middle goes on the bigger, plus 9 minus 4. Yeah. So, right? Because they multiply to be negative 36, and 9 take away 4 is plus 5 in the middle. So I got those. And then now what do we do from here? Now we set each part equal to 0, each part that has an x. So x minus 4 is 0, or x plus 9 is 0. Right? What about that 6? Who cares about that 6? Now you may think, what are we talking about? Well, think about it. Think about what this is really saying logically. It's saying 6, just plain 6. There's no letter, no variable there, times some number. Why do I say this number? Well, it's got an x. We don't know what it is. Times some other number, because this part has an x also. We don't know what it is. Equals 0. What if I told you, real life, 6 times something is coming out 0? How could that be? Well, either that first thing is a 0, and the second thing could be whatever, like 3 or whatever. 6 times 0 times 3 would be 0, wouldn't it? Or the first thing could be whatever, 7 or whatever, and the second thing could be 0. 6 times 7 times 0 would be 0, wouldn't it? So basically, either one of these two could be 0, and the 3 and 6 times the two of them will be 0. So the 6 has nothing to do with it. Why? Because he doesn't have an x, right? Anything that doesn't have an x can't vary, doesn't have a variable. It's just 6. So 6 times two things that can vary coming out 0. That means one of those two things could be 0. Either one of those things could be 0 to make it true. So then finish it up from there. Bump that over. Positive 4. Bump that over. Minus 9. So I got my two x's. That means this one is happening. Oh, this point right here. Yeah. Oh, we probably could have guessed over at 4. And this one is happening. Yeah, back at negative 9. I guess we could have really just looked at that picture, huh? All that work. I guess we could have. We might have been not sure if it's right there. It is. It's right at positive 4 and right at negative 9. Now, that we don't have the y values yet. We got to get the y values. Those are the x values. By the way, if you have trouble with this factoring, you could do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That, and just put in this as a, b, and c. And you get the same two answers. You get 4 and minus 9. You can always do that instead of factoring. Okay, anyway, we have our two x values. How do we get our y? So they want the y height, max and the min. You plug them into the original function, right? Because that's y. Function values are y values. F is y. So they want the y height. So we did, don't be confused. We took the derivative, set it equal to zero to find the two x values, because where the derivative is zero, zero slope, you're going to find the max and the min. And then once we got those x values, then you're going to plug them into the original y to get the heights at those x values. So I'm going to do that on Desmos. I'm going to go plug that in. Let me write down that function and we'll go there. So 2x cubed plus 15x squared minus 216x plus 3. All right, and we're going to plug in 4 and negative 9. So I'll plug in 4 first. Here we go. Let me clear that. Okay, so 2x cubed, so 2 parentheses. What am I plugging in? I already forgot. What am I plugging in? Plugging in the minimum, so that'd be at 4. Plugging in 4, that's right. 4. Cubed plus 15x squared plus 54 squared minus 216 minus 216 times 4 plus 3. And there we go, minus 493. Minus 493. And that is the minimum, right? We just plugged in 4 to the original function and got minus, right? I plugged 4 into this function. Is that making sense? So I'm going to plug, let me write what I did. I plugged 4, x equals 4 into y equals 2x cubed plus 15x squared minus 216x plus 3. That'll give me, and it came out to be 493. And now I'll plug in the other one. Plug x equals negative 9 into same thing. Plug it in. So make it negative 9. Just go back to Desmos, make it negative 9. Wherever that 4 is, make it negative 9. And there it is, 1704. Is that the answer? 1704. We got it. So that's what we do. So recapping again, take the original function, take the derivative, and set it equal to 0, because where the derivative is 0, you're going to find the mins and the maxes where the slope is flat. So I solved this equation by factoring, got my two answers, which really I could have just seen them on the graph, and then take each of those x values and plug them back into the original function to get the heights. Let's do that on Desmos, and you get the heights, which is what they want on that question. There we go.